Hi everyone, this is Mrs. Hamill. I know that the lesson about writing the equations of parallel and perpendicular lines might have been a little confusing yesterday. No worries, I will be out all of this week and probably next week, but starting Thursday we do have somebody that is an actual math teacher that used to teach at West who's going to be coming in to help you guys. So do the best you can for the next couple of class periods, and then that teacher will be able to review what you've learned these last couple of days and give you some assistance with anything that you're not understanding. So today we're going to talk about congruent figures. We're going to specifically focus on triangles because that's what we've been working with this unit. And to start with, we're going to lay the groundwork for some of the triangle congruence properties and theorems that we are going to study the rest of this unit. So remember that congruent figures are any two figures that have the exact same shape and size, which means that not only are they the same shape and size, but their corresponding parts, in this case the angles and the sides of a triangle, are in the same spot for both figures. For example, if we know that the line segment AB, it would be congruent to DE because those would be the corresponding parts of that triangle. BC would be congruent to EF because they correspond. And then AC would be congruent to DF because those are the parts that correspond. In the same manner, we can say the same thing about the angles being congruent. So we can look and say that angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. So those corresponding parts are important to match up when we're talking about congruent shapes. So the next thing we're talking about is the congruent figure. So again, these two figures are going to have all of their corresponding angles congruent, and all of their corresponding sides are going to be congruent. The way that you're going to be able to tell which angles and sides are congruent to each other is by the order in which the shape is named. We've talked a lot about the importance when we wrote a congruent statement of the shapes being labeled exactly the same so that you know which order that you're going to match those shapes up with. And this is where that really becomes important. If I know that triangle ABC is congruent to triangle DEF, we can tell which parts of the triangle are congruent to each other by the order in which those triangle names are written. So for example, in this case, angle A and angle D are going to be the ones that are congruent because they are labeled first. Then comes B, so B is going to become congruent to E, and C is going to be congruent to F. And remember that those angle markings, a single line, those two would be congruent. The two that have the double line are congruent. And then the two that have the triple line are going to be congruent. In the same way, when we look at naming the sides, AB is written first. So that would be this side here. Then DE is written first in the other one. So that means that AB, that line segment AB, is congruent to DE. In the same way, BC would be congruent to EF. So we can write that. BC is congruent to EF. Again, paying close attention to the order in which that we are writing those statements. And then the last side that's left, since we know these triangles are congruent, we then know that AC is congruent to DF. We'll write that over here on the side. And remember that when we're writing congruent statements, we always want to use the segment segment notation above the letters, so that tells us that we're talking about that line segment AC being congruent to that line segment DF. So when we see these two triangles, we can say they are congruent because all of their corresponding angles are congruent and all of their pairs of corresponding sides are congruent. So when you have a congruent set of congruent triangles, you should be able to mark them up just like we did on triangles ABC and DEF to show which angles are congruent and which sides are congruent. So in this first diagram, these triangles are not labeled, so first we're going to label them. So they told us in the given information that ABC is congruent to DEF. So triangle ABC is congruent to DEF. And even though those two triangles are flipped around, I can still clearly see which angles would be able to match up to each other. So again, angle A would be congruent to angle D. Then B comes next, so B is congruent to E, which is listed next. And then C is congruent to F, which is listed next. Then we can also label our congruent sides. So again, we list AB first, and they list DE first. So that's the two sides that are congruent there. Then my next side says BC is congruent to EF. And then my side that's left, AC, would be congruent to FD. So when I'm looking at my corresponding angles, angle A is congruent to angle D. Angle B is, angle here, fix that. Angle B is congruent to angle E, and angle C is congruent to angle F. Our corresponding sides then, side AB, that line segment, is congruent to ED. Our line segment BC is congruent to EF, the line segment. And then last, we can say that AC is congruent to DF. Again, paying very close attention to the order in which we're labeling those to ensure that we know exactly which ones match up. So in the next section, we're asking, can these following figures be proved congruent? So right now, the only way we know to prove them congruent is to use that corresponding parts theorem. So in order to say they're congruent, we have to be able to know for sure from the markings that are there that the angles are all congruent and that the sides, their corresponding sides, are congruent. So let's look at this first example. In this example, I can clearly see that my sides, those two sides are marked congruent. Then I have 2 dashes to 2 dashes, so those two sides are congruent. And then I have 3 dashes to 3 dashes. So I can see that the 3 side angles are congruent. Then I want to take a look at my corresponding angles. So we can see that D and H are the congruent because they have the same measurement. These two angles on the inside are going to be congruent because they're vertical angles. Well, we already know that if 2 angles from the triangles are congruent, the third has to be because they have to add up to 180 degrees. So therefore, we can say that angle E is congruent to angle G. So since we've been able to show that all of the corresponding angles and the corresponding sides are congruent, we can conclude that yes, these are congruent. And we're going to write a congruent statement. So triangle DEF is congruent to triangle And this is where we have to be very careful when we label this. Angle D matches up with angle H. So we're going to want to write triangle H. Then the second angle, angle E, matches up with angle G. And then we have angle F. So we have to write those in the exact order so that we know which angles and sides are congruent to each other. So in this case, we have angle D is congruent to angle H. Angle E is congruent to angle G. And then because there's more than one way that we could label F, we're going to use the full angle measurement. So angle DFE is congruent to angle HFG. Again, making sure that we're paying very close attention to which pieces of that triangle are lining up with each other. Then we can also look at our sides. So DE is congruent to HG. DF is congruent to HF. And EF is congruent to GF. So the reason that we can say that they are congruent is we can say that the triangles are congruent because there are three corresponding sides and angles are congruent. We can prove that because we were able to show all of those angles and sides matching up to each other. Okay, in the next example, we are looking here, and the first thing I notice is that there's no congruent markings on my sides. So as soon as I see this figure, I'm like, okay, this triangle is a scalene triangle, which remember we said means that it doesn't have any congruence at all. So when we look at that, we have to say, no, this is not a congruent. These two triangles are not congruent to each other because we can't prove all of the corresponding angles and sides congruent. So again, because, we can visually see also that this OP side is definitely not congruent to MN. So even though there are some congruent angles right here and right here, we can clearly see that those side lengths did not measure up. So since there's no congruent markings to prove that all of the corresponding sides and angles are congruent, then we have to say, no, these two triangles are not congruent. So in the next example, we're going to be given, so this is where, again, it's really important for us to pay attention to the order in which our congruent statement is written. So MKL is congruent to JET. So again, I can read this statement and I can say M is congruent to J, K is congruent to E, and L is congruent to T. And we know that because of the order in which the congruent statement is written. Then I know that MK is congruent to JE, and KL is congruent to ET, so that leaves these last sides congruent to each other. So once I do my marking